Hi U9s, today we're going to look at area and volumes of similar figures. Okay, let's have a look at these three figures, and our goal today is to look at the scale factor. If the scale factor of the side length is n, what do we call the scale factor of the area, the surface area, and the volume? To do so, we have over here three shapes. Let's call the three squares A, B, and C. And we're going to compare this. So let's compare A and B first. Then we're going to compare A and C. And guess what we're going to compare last? B and C. We're going to compare and see if we can find a pattern. Now the scale factor for the length, we're going to call it N. Let's have a look. So A and B, the scale factor is 4 and 2. So 4 over 2 is 2. The scale factor of A and C is 5 and 2. So 5 over 2. That doesn't simplify, so we're just going to leave it like that. And the scale factor for B and C is 5 over 4. And again, that doesn't simplify. Now let's have a look at the scale factor of the area. Can we find a pattern there? Now the area of the first shape is 2 times 2 is 4. The area of the second one is 4 times 4 is 16. And the area of the last shape, 5 times 5 is 25 centimeters squared. So looking at the areas, we're going to try to find if there's a pattern with the scale factor. So the area A and B, when we compare them, so 16 and 14, 16 and 4. 16 and 4 is 4. We can see that there's a pattern here. 4 is the same as 2 squared. Let's see if that same pattern, which is the scale factor squared, repeats for the other two. So let's do A and C this time. So the area of A and C, the scale factor is 25 over 4. And 25 over 4 can be written as 5 over 2 all squared. So this pattern is again continuing. What about the last one? Scale factor for the area for B and C. So now we have 25 B and C. So B is 16. And yes, this can be written as 5 over 4 all squared. So we can see that if the scale factor for the side length is n, then for the area it will be n squared. So the area is n squared. We're going to scroll a little bit, have a look at these ones, and then we're going to find the pattern for the surface area and the volume. So again, I'm going to label my cubes A, B, C, A, B, C. They're the same shape, but on this side we're going to do surface area, over there we're going to do volume. So for the squares that we're going to compare AB, AC, and BC. We're going to do the same for volume. Before we find the pattern, we're going to find the scale factor for the side length, which we will call N for the side length. Now for the side length, we have it the same as the values before. So I'm just gonna write them down. See if I can fit both into one page, which I don't think so. Whoops, ignore that. Does it fit? Oh, yes, it fits. So the scale factor for AB was, for the side length, was 2. The scale factor for AC was 5 over 2. And for BC, we saw that it was 5 over 4. Now let's look at the surface area. So the surface area of cube A is 2 times 2 times 6. So 2 times 2 times 6, which is 24 centimeters squared. The surface area for B is 4 times 4 times 6. So the surface area is the area of one side times 6. So 4 times 4 times 6, which is 96 centimeters squared. And for the big cube, we have 5 times 5 times 6, which is 150 centimeters squared. So now let's look at the scale factor of the surface area. So AB is 96 and 24. So 96 over 24, and we can see that 96 over 24 simplifies to be 4. Now we look at AC, so that's 150 for C, and A is 24. And if you use a calculator, this simplifies to be 25 over 4. And BC, finally BC, we have 96 and 150, so 150 over 96, and on a calculator that simplifies to be 25 over 16. Can we find a pattern between the two? Well, 4 is the same as 2 squared, so it's the same as this squared. 25 over 4 is the same as writing it as 5 over 2 squared, which is the same as this squared. 25 over 16 is the same as 5 over 4 squared, and again it's that squared. So the surface area scale factor is n squared. We're going to put it up here, n squared. Surface area for volume, let's look at the volume. So volume of A, 2 times 2 times 2 is 8 centimeters cubed. The volume for B is 4 times 4 times 4 is 64 centimeter cube, and the volume for C, 5 times 5 times 5 is 125 centimeters cube. Let's find the scale factors of these three shapes. So AB would be, what is AB? So 8 and the 64, so 64 over 8 is equal to 8. And we have the scale factor for AC, so that's A and C, so 125 over 8. Oops. I'm writing and you can't even see, sorry. Let me scroll there. So the scale factor for AB was 64 and 8. The scale factor for AC is, A and C is over here, 125 and 8. And the scale factor for BC, B and C, is 125 and 64. And we can see that 8 is the same as 2 to the power of 3, which is that to the power of 3. 125 over 8 can be written as 5 cubed over 2 cubed, or 5 over 2 cubed, so it's that cubed. 125 over 64 is also, we can also write it as 5 over 4 cubed, and again it's that cube. So we can see that the scale factor of the volume is the scale factor of the length cubed. And an easy way to remember this is the units of area and surface area is squared, so the power squared, and the units for volume is cubed. Let's see how we use this. Before we move on, just a quick reminder, and I'm going to type it so it's nice and clear. Oops, ignore that. Text box, so I'm going to type it over here, that if you have the original length or area, surface area or volume, so if you have the original and you multiply by the scale factor, you end up with the new value. So make sure that you know that. And the other thing to remember is that the scale factor for the factor, if we let the scale factor for length, oops, I can't spell, equals to n, then the scale factor for area we said is equal to n squared. Oh, I'm going to put the squared later. For surface area, hang on. Okay. So if we have the scale factor for, I'm going to draw, sorry. So if we have the scale factor for the length as n, then the scale factor for area will be n squared. For surface area is also n squared, and for volume is n cubed. So the scale factor goes in here, and all original times scale factor equals new. So let's read the questions. The side lengths of a box have been increased by a factor of 5. So that is the scale factor of the length. So n equals 5. Find the surface area of a new box if the original is 10 centimeters squared. So again, we're going to use this formula over here. So the original is 10 centimeters squared. So we have the original times, what is the scale factor for surface area? The scale factor for surface area is n squared. And we have n as 5, so 5 squared. It gives us the new surface area. So let's do that. 10 times 5 squared. 5 squared is 25. It's simply 250 centimeters squared. Units over here. Find the volume of the box if the original volume is 8. Again, we're using this formula up here. So original is 8 times the scale factor. Scale factor for volume is n cubed, and n is 5. So it's 5 cubed. And we obtain, put that in the calculator, 1,000, don't forget the units, centimeters cubed. Find the area of the original square if the new square is 100 centimeters squared. So we're looking at the area. I'm going to use a different color so you can see better. So for the area, our scale factor is over here. But this time we're looking for find the area of the original. We want the original and we have the new. So I'm going to use this formula again, but I'm going to write original is what we're looking for. Original times the scale factor for area, which we said was 5 squared, gives me the new, which is 100. Now, how do you cancel out multiplication? You divide. So let's do that. Just scroll up so you can see. So dividing by 25 on both sides, we have the original square is equal to 100 divided by 25 is 4. And the units here, centimeters squared. Okay, that's it from me today. So you have the scale factor patterns here. Original times scale factor equals new. Please go ahead and do exercise 5.5 and I'll write a very short quizzes for you to do, and I'm going to mark your attendance from the score on your quizzes. Copy the notes down. I'll see you next time. Bye.